Hey, how's it going, everyone? Welcome to the stream. All right, so last stream we were working on parsing variable types and local variables in our RstParser over here. And when I left last time, I actually should have just shown it working. I wanted to show this now. So basically what we did was we worked on specifically this NLSim here, the type for the stabs type that is used for both local variables and for type definitions. Basically, like we need to parse out like all the data types that are defined. There's the basic types, like the primitive types, int, char, and all that. And then there's a user-defined types. And I'm focusing right now mainly on the int type. So I have this like hack over here that's like if the type is int, whoops. If the type is int, we use it, otherwise we return. And we create a primitive type and we add it to our debug symbols. And otherwise, if it's a variable declaration, we go and we parse that out correctly. We find the type that it refers to. So that's this type ID to type. We do a find there, and we set it and we add it to this current variables vector that I have up here. And what I wanted to show, and I didn't show this last time, is if we try to run this, given that we have this very simple, where is it? My simple program here. This one here where we have just a couple of ints in main. All right, so I have a breakpoint here. We're parsing RST files. The very first one we parse is, let me see here. Can I see which one it is? It's the crt0.rst. So that one has no variables, and you'll see that sure enough, current variables is 0. So we'll just hit F5. And we now just parsed main.rst. Yeah, there it is, main.rst. And we can see here that we have, I think I'll make it a little bit larger. So here we can see we have two variables. We have one variable A and one variable C. A refers to this type here. The type is basically the integer type that has a byte size of 1 and is signed. And we'll notice here that it is exactly the same type that is used for C, because that's also an integer. So it actually refers to the exact same, it's a shared pointer, so it points to the exact same type here. So this is working. So that's cool. So what we're going to do today is we're going to focus on the part that feeds this information to the debugger itself. So we're going to move to DAP. And oh, actually, before we do that, we need to, that's right, yeah, we need to implement the scope stuff. So like I was saying last time, now we got to start parsing this whole section right here. The part that defines the function, defines all the variables and the scopes for that function. So, yeah, so let's do that. I think I'd like to commit what I have just because it is working, even though it's incomplete, but it's coming along. So let's see here. Add type. Looks good. Okay, that's it. So I'll put here RstParser parse lsim stabs, which is type def or variable decal. All right. Now, for the function, we already actually are handling this. So here we go. So we get a function name, we get a label. I think what I'm doing right now is I am making sure to add that symbol for the function name and the function address. Yeah. So now what we want to do is, okay, let me just look at this. Okay, so I have a current function here. Make unique function. It has a name and a scope for now. I might add address, we'll see. And for the scope, we are going to create a scope for this function. And we're going to set our current scope to it. Actually, I can't do that with... Yeah, that's true. So I guess I won't, that's a good point. What do I do here? I suppose I could use a raw pointer here because ownership is managed by the function, so I don't have to worry about leaking it. Unless I just want to use shared pointers everywhere. Not sure yet. Let's start off by making this raw pointer. I need to track the current scope. Yeah. Okay, let's just see how this goes. So let's do this. Yeah. Okay, so we create this, and technically speaking, I guess I could add my function to debug symbols. I guess I could do that here. Not add symbol. So this would be like add function. Yeah, that's the problem again here, is if I add it, I no longer not obvious what to do here. So the problem is if I add it here, it's a unique pointer, so then I'm transferring ownership, but I need to keep having a pointer. So it's the same problem I'm having with scope. Do I want to keep raw pointers? Do I want to just deal with shared pointers? Does it really matter? It's kind of like I only need shared pointers while I'm doing this parsing. after the fact, I don't really need them anymore. Alternatively, what I could do, excuse me, is if I could track when I'm done all the parsing of a function, I could add everything to the debug symbols at the end. Excuse me. My only concern is, will it be obvious to me when I'm done with a scope? Also, one thing I realize is I don't have a way to go to my parent scope, do I? Oh no, I have here parent. So yeah, definitely have a way to go up. So then maybe okay, you know what I'm going to do? I'm not going to add it here. I'm not even going to add this scope here. I've got a function. I'm going to make it, and I'm going to set its name. And that's it. I'm going to bring this back to we'll see about this. All right, so we do this. So we've got our function. Next, we're going to start parsing our variables, which we already did. And then it's this guy here. So 192 and 224. So these types. .192. So that's 0xC0. This will be left brace, open scope. And then we have the right brace, which is 224, which I guess I didn't write down here. E0. Okay. I'm wondering if I should be adding a state to parse those functions, but I don't think I will. All right, so that is a stab n. So this is one of the, it's not a string. It's not a stab d. So this is the first time I have a stab n actually. So what does the N stand for again? I guess I never documented what the stab N stands for. So let's see here. See, they show here S, N, and D. Do they explain what N means here? So I know S is for string, and D is for, was it decimal? Oh, D is for dot. I don't remember why they call it a dot directive. I guess for the dots in the code, like dot text, I suppose. That would make some sense. Like here, these are all dot directives. And then N, not sure. There are 3 overall formats for stab assembler directives differentiated by the first word of the stab. Number, it's right here. Can't read. It is either string, number, or dot. Okay. In general, in the dot stabs, the string field contains name and type information. For the stab D, the value field is implicit and has the value of the current file location. Otherwise, the value field often contains a relocatable address, frame pointer offset, or register number that maps to the source code element described by stab. The real key to decoding the meaning of a stab is the number in its type field. Each possible type number defines a different stab type. Okay. I mean, it doesn't really matter, right? Whatever. So it's a stab, it's a number. It's going to look something similar to this. I should probably rename this to like stab string, stab dot, and stab number, because it's really hard to see them as anything different with just the one letter. Yeah, I'll probably do that. So let me grab my example here. And what we're saying for n is, okay, so it's got the value as well. Type 0, description and value. So 1 is type, 2 is other, 3 is description, and a value. Two, 3, 4, 5. 1, 2, 3, 4, 5, and then I have 3 here, so 1, 2, 3, and I need an extra one here. There are 4 to capture, so an extra one of these. Like that. Okay, so let's collapse this for a sec. Stab number directive. Okay. The type is pretty much always that one there. Match of 1. In this case, it's match of 2. That's true. So let me do this. Const int type equals s to I, match of 1. Same thing here. If type is equal to n albrac. Okay, so if we hit an n albrac, then what we want to do is we want to add a scope. Yes. So we go like this. Indeed, we want to, okay. Let me just write this down. So create a scope and transfer all variables we've collected so far. So variable declarations we've collected so far. So we move variables. I think it's cur variables. And I think I need to reset this because after move, it's technically not valid anymore. It needs to be reinitialized. I think stood vector you can start pushing back on it after move, but I'm not sure. Is it in an unspecified state? So let's say 7. After the move, other is guaranteed to be empty. Does that mean I can push back on it? I don't know. Okay, let's assume we can. So we move the variables into the scope. Then we take the current function and we're going to do add scope. Or maybe push scope or something like that. So I'm going to go and add something like this. this is one direction I can take, whereby I keep going through the current function with the scopes. No, I can't do that. I need to have a concept of current scope, because if we close a scope, I need to go to the parent, and I need to know that we're at the parent. Yeah, so that's not going to work. Okay, so let me go back to this idea of having a current scope. Yeah. Okay, so come back to this. So if I don't have a scope yet, and I've just created one, set it as the root scope, the first scope of this function. And or maybe I'll make it a bit more clear by doing this. If it's the first scope for it, or add the first scope to the function. Actually, yeah, I'm gonna need to do this. Make current. All right. So now we have a scope. We've moved our variables to it, and that means the variables have been cleared. Now we're going to add some more variables. We get another scope. We're going to create one, move the current variables to it if there's any, and make it the current. Only add the root one. So now what we need to do is when we hit a closing scope, all we need to do for that is just move our current scope up. Now, of course, we haven't properly created that, so we need to do this, cur scope, which means that this has to be null when we're done. Yeah, very, very carefully have to manage that. So let's say we're going to need a constructor here. Okay, so when we create a scope, we tell it that this here is its parent, and then we replace it with the current one here. give me a second. Okay. So yeah, I'm just thinking about whether or not I want to like do something here, because I have the concept of children, right? So I'm not really doing the children stuff here. So maybe I'll do it in here. So this is the parent. Oh yeah, I can't do that here. I think I'm going to have to go for shared ownership to keep this code simple. Yeah. Okay, so yeah, I'm pretty sure this is what I need to do here to keep this code working in a simple fashion. I'm going to go with shared pointers here and just make it so that I can have multiple pointers and not have to worry about it. Now, one thing here is this scope that I had is the parent, and I need to add this node as its child. I could only do that within the constructor if this guy is derived from enable shared from this. Not a huge fan of it, but it does mean I can sort of simplify this code here, because now I can say if parent is valid, right? Whoops. If the parent is valid, then I can do this. I can say add parent dot pushback, sorry, parent dot children pushback, and now I can actually say shared from this. So that's one advantage to using enable shared from this. Otherwise, I'd have to do it from the outside. So I think I like that, because now this call here takes care of the parent-child relationship. I could now seeing as I made it a shared pointer, I could make this a shared pointer as well. I think this here should complain because I'm passing a shared pointer to something that wants a raw pointer. So I expect to complain. I'm just going to wait for the compiler to see that. So I want to move the variables. I guess technically that's what I was thinking, is that maybe I should also make the constructor take the variables here as well. I don't know. On the fence. So make current. So I can just do this because now it's a shared pointer. So that's what I like. And add, so this is it here. So I don't really need to move it in that case because now it's shared. And this is shared, right? Yes. Okay. And then finally here I want to say current scope is equal to, now the parent is a raw pointer. That's not as cool. So what if we added a function to get the shared pointer to the parent? Closing scope, set current scope to parent. Now, of course, this means we must have one. Wouldn't make sense if we didn't, but we shouldn't see an NR brac, like a right brace, without having a current scope. And what about the case of we reached the null pointer? Yes, so that's possible. So this was the root, then this would actually return a null pointer. Is that a problem for me here? I think it is. I need to check that here. My parent might be null. If I have a parent, do this. Otherwise, return an empty shared pointer. Yeah, that's good. Okay, so I think if I got this right, this should be it for parsing. Let me see here. So in this example, I'm going to collect these two and then just see these two. So I guess we could debug that and see if I got this right. I'll put a breakpoint in there and a breakpoint in here and one for the function. Okay, so here's my function. This guy is, so maybe I should make that guy shared as well. So if everything makes sense, actually my current scope should already be null at this point. You know what I mean? Should be null when we hit a new function, as we should have reached the closing as hitting the last scope of the previous function should have cleared it. So we will add a function this way, keeping it shared. Right, I am going to need a mapping of the function by its address, which means I should store the address here anyway, so I think it's useful information. At this point, there's obviously some overlap with this concept of a symbol. I might end up removing symbol. We'll see. It might be less useful. So it's got a name, it's got an address. Maybe I'll make a constructor here as well. Move the name, put its address. In that case, we can have very similar to this address to symbol. We'll have address to function. We'll get a add function here. Handle if function already exists at this address. So that's going to happen for like inline functions. I think it's okay. We'll see. Because what we need to do is we're going to, when we parse multiple files that include the same headers and those headers define inline functions, we just need to pick the first. This is the, in C++ and in C, I suppose, this is that whole rule of like the first definition is the one that matters, and all definitions are expected to be the same. It's also known, it's called the one definition rule, ODR. So the compiler is allowed to assume that, and you have to be very careful not to violate ODR. So like sometimes with poor usage of macros, you can include the same header with a different set of macros defined, and that can give you a different layout for data types, which means that you've actually violated the one definition rule. So that's the kind of thing. The reason for ODR is because of C++'s inclusion model, which comes from C, this whole idea of including headers, and that it's basically a text parser. Because of that, we have to make compilers simple and not to require them to validate that the multiple definitions are all the same, and also just not to waste time doing that. There's a rule that says the very first definition, or all definitions, are considered equal. So it's on you, the onus is on the programmer, to make sure you don't violate this one definition rule. We're going to want to do the same thing here. Okay, so we create a function. So now I need to initialize my function here. So func name. In fact, I think I'm going to give it, yeah, okay, and then func address, like that. So I don't need to do this. And then I can add it to my debug symbols, and I can keep tracking it like this as a current function. Oh, another thing I wanted to do is if cur scope, so if we no longer are parsing a function, if we reach our last scope, I can set current function to like null. This could have also been the place where I add the function, but I don't need to do that, right? Maybe I should, because that could actually move it in that case. Okay, let's do this. Assert that the current function is null. Assert that the current scope is null. Create one. Turn off my notifications on my phone. Okay, and then I will do this. So when we hit no more scopes, we're gonna do this, and we're gonna move it. So we can move a shared pointer, which means that there won't actually be an extra ref count deref for no reason. And I'm gonna reset it anyway, because I don't remember if a shared moved from shared pointer. Yeah, I think it's okay. We can just do that. That's the beauty of using these types. So we move from it, and it will be in a state where it can be reassigned, and it's considered null. Just to double check. So it's number 10, I suppose. Move constructs a shared pointer from R. After construction, star this contains a copy of the previous state of R. R is empty, and its stored pointer is null. So that's what I wanted to see. Okay, it's good. On the last closing scope, we're done defining the current function. So technically speaking, like this current scope here that we're setting, another thing we could do is rather than add it here, I could climb up to the root scope and add that one to the function at this moment. You know? Like rather than on the very first scope, add it to the function, on the very last scope, I could traverse the parent chain, get to the root scope, and then add that one to the function. That's an alternative. But I think, yeah, I don't know. I think I'm okay with this. It's fine. See if this compiles. Okay, it does not compile yet. My favorite template errors. Okay, Okay, so scope ref cannot convert argument 1 from shared pointer to scope star. Okay, so that's, I think, is the one I was saying was going to happen. Let's see. Yeah, that's right. It's so annoying. You can't bring me to the actual instantiation location. Annoying. I guess I could, instead of doing this, I could accept it as a shared pointer, since we know we're going to receive it that way. And technically I should only set my parent. No, actually I could do this no matter what. The reason I need to make this raw is because I can't have cycles in my tree here. So I can use shared pointers for my children, but I must use something else like a raw pointer for my parent. Otherwise, I'll have cycles and my memory won't be released. Basically, you'll get that problem where you'll have a children pointing to a child and the child's still pointing to its parent. And when you destruct the scope, now I don't have to worry about anything, but if I had this being, let's say, a unique pointer or a shared pointer, I'd have to make sure to clear this so that on destruction, it actually does the right thing and frees all the memory. Classic problem with references and cycles. Okay, so if parent children push back. Okay, that compiles, so let's run this. All right, first file has nothing, and I've hit an assertion, so let's see what's going on here. Right, one thing that sucks about my assert handler is that I'm throwing right now, which is not going to help me much. I'm going to need instead to put a breakpoint in here. Let's try it again. Okay, so where are we now? So my function is not null when I'm about to add another one. Okay, so this means I parsed a function that didn't have scopes. I guess that's what it means. Let's go take a look. My assumptions may not hold. So let's see, we're looking at number 36 here. Okay, so this is the inline defined function that comes from the dummy header file, which I'll just open up here just so we can see it. So there's foo. So here it's saying, here's, oh, I see. So there are no scopes. I see, that's interesting. Okay, so I was under the impression that there was always going to be scopes just for the body itself, but I suppose that's implied for every function. Like if we go look at main, that's true, we have open and close, but only because no, actually, how come in this case we have scopes? Is this because we have variables? So maybe it doesn't bother defining scopes if there are no variables. Like if I add a variable here, just want to see what happens here. Let's build. All of a sudden we have it. Okay, that's interesting. So it's possible for a function to not have a scope. So I have two ways to do this. I can either model it such that my functions always have a scope, no matter what, and or that scopes are not necessarily defined for a function. I can either go with what they're doing here, which means scopes are only there for functions. If there are no scopes, there are no functions. Sorry, scopes are only there for variables. If we have no variables, we have no scopes. Maybe that makes sense. Okay. I think I'll go with that. I think we'll have less trouble doing it that way. I think it's logical. So let me go into here. And I'll write, might be, or I can say, may be null pointer if this function has no variables. So in that case, what it means then is that if I start parsing a function, I may not get to the point where I know I'm done parsing that function. So I can't assert this guy here. There's just no way. There's no way to know. See, like if I remove these again to come back to the state we were in, once I've parsed the stabs, I don't know I don't really know I'm done with it, you know? So I cannot do this assertion. They still point to the last one. This happens if the function has no scopes, no local variables. I think even like if it has parameters, would it do it? I think parameters count. Let's see here. Nope. Parameters. I'm not handling parameters yet, but you can see here that A is a parameter of type 7, but there is no scope created for it. Yeah, so scopes are really there for local variables, as one would expect. Parsed at this point. Okay, so let's build and run again. We should now be okay with, since we're not asserting, we're not going to hit that assert. I'll just add a little breakpoint here as well. Whoops. Debugger was faster than me. So here we are. We're about to add a function. We're going to add, I don't have the name, unfortunately. We're going to add another function. So this must be our main. So here we are about to add the scope, the opening scope for that corresponds to this here, this scope. We have variables. We have 2. So we're going to move those 2 into there. That's A and C. Very nice. So now current variables is size 0 and scope has that one. Current scope, which is empty, will become this scope here. My function doesn't have a scope, so we're going to copy it in there. And then we're done with that guy. And then the next time we're going to hit the R brace, so the right brace. We have a scope. It doesn't have a parent, so when we do this, this will be null. And since I don't have a parent, we're going to add a function. We're going to move the current function into the debug symbols. So now current function is empty. So when we reach the bottom here, current variables is 0 as expected. Current function is empty as expected. And in debug symbols, address to function, we have one entry that maps from address 98. Let's go see if that makes sense. I think it does. Yeah, so main is at 98. So that's good. Okay, great. So we did all that. Now let's go to the DAP portion. So now what we're going to do is we're going to go and implement the callbacks for the debugger, for the scope requests, and the variables requests that go with the scope requests. It's exciting. Take another sip. Okay, so let's bring back the request here. Because what we're going to do is we're going to read the frame ID from the request. Now the frame ID is our frame address. We know this because that's what we set into frame ID somewhere else. Part of the stack trace here. Let me see. Trying to remember what I did. As I built frames, I had to set here frame.id. So I'm going to say here request corresponds to the stack frame ID. Is that what it was? Yeah. ID. Okay. We set earlier when building all right. So scope request corresponds to the set we set in the stack trace request. So here we know that it's our frame address. Now look up scopes for the current frame address. So this is where we take our debug symbols, and we're going to need a get function where we give it a frame address. Do this. Right, can't use that operator, so it's actually going to be second. think that should be all right. So get the function by address, like this. Right, it's not a pointer. Okay, make sure this builds. Okay, good. So now we have our function. We're going to want to get our scopes. So for each scope, we're going to want to iterate through all the scopes. Maybe I can make a little callback for that. And then for each scope, we're going to want to say, give me the scope name, presentation hint, and then variable reference ID. So that's all right. We don't populate variables here. We just say, here's a scope. We just give it all the scopes. And then when it wants the variables for each scope, it's going to ask for them. That's right. So I need another mapping, I suppose. Or maybe I could just put the address of the scope. It's not super cool, but maybe we could try that just to start. I think what would be nice here is to have some kind of function to recurse. I'm going to start with scope and then I'm going to generalize it after. And we're going to give me a function that I could call back. And we'll do like an in-order traversal. So a very simple in-order traversal of this tree, like that. No, sorry, not recurse. I want to say traverse. And what we'll do is we'll traverse the function scope with a callback that accepts a scope. me make sure this builds. Okay, looks good. It's complaining about unreferenced variables. If I do this, it should build. Okay, so now that we do this, what I can say is start creating these DAP scopes. I don't know what to call it. It's getting confused here. I'm going to call this a DAP scope. Now for the variable reference ID, I think what I'm going to, this is what I was saying before, I don't have a great solution for this. So what I'm going to do is I'm going to do a DAP, that's a DAP integer. Of hoping that this actually fits in there. I guess not. No, that won't work then. Because basically what's going to happen is when we get called here, we're going to want to grab our variable's reference ID here. And then do our lookup and then fill in all the information about that variable. The variables of the scope can be retrieved by passing the value of variable's reference to the variable's request. Exactly. Because I have this tree structure, I don't really have like a lookup structure. I don't keep my things separate. So what I'm going to have to do here is in effect store some kind of unique mapping of integer to scope here, so I can grab my variables for it. All right, because I have no choice. So then what we'll do, let me just put a little to do here. Move into, I'll say create a tree node base and move this into it. All right, so when we add a scope, see, I don't even add scopes because I add functions. I don't know. Okay, I have the function here. And I'm getting all of its scopes. This sucks. Why do they do it this way? Is there some kind of advantage to separating the scopes from the variables this way? If there is, I'm not quite seeing it. It seems to make sense to me to want to store it this way. But the way they're doing it, it's kind of like you'd want to have a mapping from functions to scopes, I suppose. And then each scope would have an identifier that allows you to look up a container of variables for it. So maybe what we could do is actually store this thing in the DAP debugger. It doesn't really belong in debug symbols. This was kind of weirdness. So just to see how this would work, I'm going to do it up here and then we'll move it in as a data member. I just kind of want to mess around with it in the CPP file first. In fact, I guess I can make it a weak pointer. The reason to make it weak here is just, I mean, I could make it shared, I suppose. I'm not sure. It's because I want to make sure that if I were to clear, maybe I'll make it shared. Should be okay. So the very first time that we come in here, one thing too I have to be sure is that I haven't already added this scope. So let's hope that the debugger only asks for it once. Alternatively, I could just make it so that the scope has a unique identifier for it, I suppose. Maybe I'll do that. I don't like it because it means now the scope has this concept of a unique identifier, which is kind of weird. Okay, let's just start with this and see how it goes. So now in this case, I do need the shared pointer. So let's change our traverse. No plus plus on DAP integers. Okay. So consider storing an ID in scope. There's a danger of assigning multiple IDs to the same scope if the client asks for the scope multiple times, for the same scope multiple times. Okay, let me just change this into an int because it doesn't know how to hash DAP integers, which is fine. It doesn't matter. DAP integers is the wrapper for int anyway, so no big deal. Okay. Okay. And one thing I need to do is I need to push this back into the response. So let's create a response object at the top. Let's push it back in here. I'm capturing it anyway, so that's good. And I can return the response this way. All right. What's the problem? Oh, right, DAP scope. Not to be confused with my own scope object. All right, I think we can actually see if this gets called and if I'm populating it correctly now from the debugger. So that's going to be kind of interesting here. Let me, where's my wait for? Here it is. Revive that guy, put a breakpoint in here. Build. Okay, so let's give this a whirl. Hit F5. Launches Vectrexy. We get a chance to attach to it. All right, so here we are, apparently getting a scope request. So let's see. I've got an address, 98. We know that's our main. So let's see if we find a function. We do indeed. Let's put a breakpoint in the traverse. So this should get called back once. So let's see. So there we are. We're getting called with a scope. If we look at our scope, it is the one that has 2 variables in it. Indeed, it does. Let me remove hexadecimal display. No parent, no children, and 2 variables. What just happened? Okay. That took a long time to execute. 3.362 milliseconds to add a shared pointer to a map. All right. So the variable's reference gets set here, its value is 0, and then we're going to increment it for the next time. We push the scope here. So we're done. Our response has one value in it, and that's what we send back to the debugger. And you see it says locals here. So the reason why it's not populated is because it is sending now the next request, which is the one for variables. So let's implement that guy. We are getting very close. All right. So this is variables request. So the request variables reference is what we're going to look up in our map. So not like that, like this. So that's my shared pointer of const scope that I've got here. Okay, so now I've got one. Now I got to go and create variables for each of these. So for each variable, let us create one of these dudes. The name of the variable so I have the name because I stored it. Now the value of the variable, that is not something that I think I took good care of just yet. But let me just go see what I've got in variable. I've got a type. Yes, I must read the value from the stack. And then I gotta do some kind of type casting and all that. So let's go get, right, so this is where we got a bit of work to do. For now, I know I'm dealing with unsigned or signed byte value, so I should be okay here. So var.address, is it? Stack offset. That's right. We get the stack offset. We got to get the value of our stack. So CPU, I think I actually had a, no, I don't have one. CPU registers, stack pointer, S. So I got the stack and I got the offset. uint16t. This will be a variable address, var address. We get our memory bus. We do a read at that variable address to get our value. Now, I should be reading you know, depending on the size, I'll have to be reading multiple values, but for now I know it's just one. In fact, I'm going to make sure of that. var dot type. So if I get my type, a type has, what does it have? Oh yeah, it's a primitive type. So I need to get which type it is. Yeah, I'm still on the fence about using a variant here. Like I said, I am doing heap allocations anyway, so I might want to do something like have a polymorphic type here, which would give me some advantages, like I could ask for its size and stuff like that, and then maybe call a virtual function on it to, you know, serialize the value for me into a string, which would be probably wouldn't be a bad idea, now that I think about it. Alright, so forget about that. I'll do that later. So I read the value here, and what we're going to do is we're going to the display value is going to be a all right. So, I mean, depending on whether it's signed or not, again, we're going to decide that later. For now, I know they're integers, so this is all hacked. Zoom int, signed char, really. Okay, so now we can say value here is display value. And the type is int. Again, I want to get the name from it. Get name type from var type. I noticed that I call this mtype, but I usually don't do that for public variables. Okay. Now, similarly to before, we're going to create a response at the top. We're going to move this in, do a pushback of the current DAP var, and then return the response this way. All right. So if I got this right, hopefully we're going to see some values. Oh man, it's kind of exciting actually. Okay, first I got to make it compile. Right. Oh, this guy still got the last one built open. Okay, so let's see. I'm going to also put a breakpoint in here because I just want to see it happen. We're going to hit F5, launches our Vectrexy. Start debugging this. Okay, so this is our scopes from before. We know this works. Huh. Oh. So we just got the same scopes request. Oh, and now we got a variable request. So let's see what happens here. So I already know now that I've got a scopes request for the same scope twice, which means that I do need unique IDs for sure. This is not going to work the way I'm doing it, but it's okay. So this at least should find me something. I have two variables. We're going to grab the first variable address here. It sets some value. Let me do this. I'm curious. Where did it go? CBE6? Yeah, that sounds right. That's a local variable. That's a stack variable, I mean. Because the offset was 0 and the stack is the stack. Okay, so we read. Value is 243. Let me see here. That doesn't look right. Maybe because it's not set yet. 243. All right, so that's not great. Yeah, so I'm going to be showing values for variables that are not actually yet in scope. Let's just see what that looks like. So that's okay, because I think until we set it, it's just got garbage in it. That's all right. Let me disable these here. I just want to see if this sort of works. So I'm going to step. Aha! A is 0. And A is 1. C is 1. A is 2. And A is 3. Holy crap, it actually works. Wow, it actually works. That's neat. That's really cool. Wow. Very interesting. I have so many questions going on in my head right now. Like, okay, let's just see. I just want to do a little bit of messing around here. Int B. Let's open some scopes. Let's, well, actually, let's do this. Set D to 4, set B to 3, another scope here. All right, let's just see what happens here. Oh, hit. So I was wondering if something would go wrong once I added more scopes. So let's take a look. Oh, here we are. So what's the problem? The problem is that I'm making a shared pointer and I'm passing it a current scope. So what's wrong with that? Bad weak pointer. Three strong refs, one weak ref. So I have a function here. It has a scope with two variables in it and no children. Okay, so this is the case of hitting the next scope, right? We want to make, so this current scope here should refer to the same one that I see in there in the function. Let me see. Pointer is 2C010. Pointer is 2C, yeah, so it is the same one. So it doesn't like something about my funky code here. Oh, it's got something to do with enable shared from this, doesn't it? Yeah. Oh, I think I know. Do I have to call shared from this in order to... That doesn't make sense. Bad weak pointer. Handle reference counting for object in the control block, no allocator. Construct in place. Okay. Oh, okay, so sorry, this is the problem. So it doesn't like that I'm calling shared from this from the constructor. Right, because I'm not fully constructed, yeah. Well, I constructed my base by now. So what's wrong with calling shared from this at this moment? Weak pointer is empty. Yeah, so I guess my shared pointer constructor has to be completed. So I can't do this kind of funky stuff from the constructor. You know what? Maybe I'll do it the other way around. Instead of constructing one and giving it its parent, I'll just do the add child thing instead. So create a scope, and we'll do an add child. Whoops. And now here I can do shared from this. Yeah, this makes more sense. Right? Actually, I don't need to do that because it just wants a raw pointer anyway. So there we go. So we add the child and we say your parent is me. So now if we come back to here, instead of doing this, we create a scope, current scope, add child, like that. If I have one. If I have a current scope, whoops. So if I have a scope, then add the new one I just created to it, and then make it equal there. Yeah. I think that should be okay. Try again. What? Oh, right. I can't assign to the child if I've moved the pointer, right? So I'm going to set this first on it, and then I'm going to move it. Set the parent first. Okay. Oh, that's funny. Oh, look at that. That's interesting. So each scope actually shows up as its own thing in here. Huh. Fascinating. Not sure that's what I want, to be fair. Looks like all the values are set correctly anyway. Huh. Okay, so one thing that's interesting is, so we see all the scopes, and I think the reason why we see this is because although they say it's optional, we should be setting the range, the lines of the scopes. And I think then the debugger will only make requests for the scope that reflects the current line that it's in. So it's going to say, give me all the scopes, and if it has that information, I presume, maybe I'm wrong, but I'll presume that it'll only ask then for, you know, while it's on line 4 and 5, it'll say, give me the first scope because you told me that it encompasses this whole range, right? And then when it gets here, it'll say, oh, now actually give me that scope. I'm thinking. If it does that, I still think we're going to end up with multiple entries, which is not great. So what I'm going to do then is, rather than return multiple scopes like I'm doing, I'm going to have to collapse them. So we'll see. We'll see what that looks like. But this is really very encouraging, I must say. This is quite cool. Like, we are actually seeing values. You know, look, I can even put my mouse. I can hover my mouse over these, and I can see their current value in there. That's pretty cool. And I suppose I can add a watch for these. And interesting. I tried to add a watch and we got a unhandled exception in IO write. That's not expected. You know, this could be though. One thing I noticed is I did not make my DAP code protected by my mutex. So let me do that. I could very well be running into a little race condition right there. I'm just going to give him one more shot to see if I could put a watch. That was a very odd error we saw there. This time I got it right away. What is this? Content length? Why am I getting this? So I am on another thread. Scan content length. An invalid parameter was passed to a function that considers invalid parameters fatal. Got a buffer. I've got 18 values to write here. So this is a CPP DAP code. So I'm not expecting to see problems here. It's the first time I run into anything like this. Very strange. Oh, it looks like it must be related to the watch, because if I remove this, I'm going to guess that it's going to work. So something with the watch it doesn't like. Yeah. I bet you as soon as I add that watch, it's going to go. Could be that there's a bug maybe in CPP DAP with watch handling. It's very possible. I should probably update my CPP DAP to the latest. I know there are changes. Yeah, see, as soon as I do that, it doesn't like it. Just quickly, let me just see what version I am using right now. Okay, so I'm here. Now if I pull, if I fetch, I just want to see how far ahead did it get. There's only one change, which is enable TCP no delay. I doubt that that's going to be the thing. This is more for a optimization. So yeah, interesting. Okay, all right. I'll look at this next time. But yeah, this is great. Made some good progress tonight. I think next time I'm going to clean up this the fact that we're going to get multiple references. I think we can't do this, so I definitely need to fix this garbage here. I'm going to say there's a danger. I'm going to say we are assigning multiple IDs to the same scope because the client asks for the same scope multiple times. Okay, so we'll fix that. And the other thing I want to do is I would like to give the line and end line here. In fact, you know what? Since we know we have, let me remove all these scopes here. And so we have only one. And let's put line 3, I guess, and line 30. Actually, let's see what the what we're going to end up extracting for that. So here we are. So LBB2 refers to this address, which refers to line 4. Okay, so it's line 4. Let's just try that. And then LBBE is this address, which is line 30. Does that make sense? It does. Okay. Just curious to see how it behaves. I mean, we're not going to get much because I only have one scope, but one thing is when we start and we're on line 3, it was making a request for the variables. Maybe now it won't until I hit line 4. Let's see. No, it looks like it's doing the same thing. Yeah. Okay, anyway. Yeah, maybe this won't be that useful. Just give me a second. LBB3 is line 9. Interesting. So this begin 3, LBN 3. So this one actually corresponds to line 9 because that's where the first actual instruction is. So let me just do another little hack here. Static int count equal to 0 if count is equal to 0. Do this. Else. It's going to be the second one, line 9, and we would get line 30. No, does that make sense? Yes, it does. Line 32, Really? Not line 12? Oh no, sorry, wrong scope. I think. Oh, line 37 is this one. Why does it consider line 32 the end of that scope? Huh. I mean, I guess technically it's okay that it considers line 32 the end of that scope, in the sense that there's nothing that happens. It's like as if it's moving this all the way down here. It's a little odd. A little odd. Unless what I should be doing is considering the previous. Oh yeah. Suppose I should be considering the last instruction of that scope, and not the beginning of the next one. Yeah, okay, so there's 11 here. Right. Okay, yeah. So then this would be 11. So I guess that also means same thing here. For the end scope here, we should be considering 36 to be the last line, which would make more sense actually. And it's still 4. Yeah. So let's try this just to see what that behaves like. Get some insight into whether these line things even help. Okay, so you see it's already showing this one here. So I would have expected it not to. So it really makes no difference. So what does that mean? Does that mean that I need to do it? Maybe I need to know? But I don't know what, yeah, I guess I know what line we're at. So I could figure out what scope we're at, and then I could decide which variables I want to display. I suppose what I don't really understand then is, why am I feeding all this scope information? So it's saying, give me all the scopes. It wants multiple scopes. I guess the idea here is a scope is really not the same thing. I think that's what it is. Here, the concept of a scope is just a bag of variables that are going to be displayed. It doesn't have anything to do with the C++ scopes here. I think that's what I have to wrap my head around. Yeah, that's what it means. So like the DAP scope can be whatever I want. I could have one called registers, for example, and just display registers. I could have one called globals, statics. I could do all kinds of stuff with it. But what we'll have for sure is one called locals. And I need to decide for that one scope which variables I want to show based on my current line. Most likely that means that I'll be looking at the current, where the PC is right now, and yeah, and then I gotta do I gotta be able to look up my current scope and parent scopes for the current function. So I'm going to have to be able to say, hey, what function am I in given my current address, which I think I can do easily because I just have to look at my call stack. So I can get my function. And then given that, I'm going to have to traverse my scopes, or say, give me the deepest scope for my current instruction address. And then from there I can, or give me all scopes that encompass my current instruction address. Something like that. Yeah, it's too bad because it's not really a nice one-to-one mapping of the term DAP scope to my scopes. But I suppose I shouldn't be too surprised. That was pretty I guess it was making a big assumption about how debuggers work in that case. They generalize it to the point where a scope is, I guess I just feel like they shouldn't have called it a scope. I think that's what bothers me here. You know, they should have just called it like variable container or something like that. Okay, so let's a couple of notes here. So DAP scope isn't the same thing as C++ scope, let's say. It's just a bag of variables that's displayed in the debugger. I need to look up the current function. I'm going to do pretty much the same thing I'm doing now. It's just when it asks for the current scope, I'm just going to return one called variables. Yeah. So for scopes request, same as now, except maybe no need to store variable reference ID to set, and in the variables request, I'm thinking look at PC value, or I'll say use get all scopes from the current function that encompass variables at, or I could say get all scopes that encompass the current PC. It's basically the instruction pointer, the program counter. Get all scopes from there and populate and return local. Return a single locals oh, right, because that's the thing. I need to add here. Right, the scope is here, and then I got to populate that scope there. Right. Or set it to a constant that means locals. Later, we might add a DAP scope for registers, for example. Okay, so if variable ref ID is equal to locals, get all scopes from the current function that encompasses and return a single and populate with all local variables of these scopes with their values. Yep, that's what we're going to do. Cool. So that was great. I'm going to stop here. So I'll see you guys next week on Tuesday. So thanks a lot for watching, and I'll see you later.